Okay, cool. So what can I do with inverses? So we're going to just dive deeper with inverses today. Um, and I'll be kind of honest, I haven't looked at these notes, so I'm going to be kind of winging it myself. So hopefully this all makes sense to everyone here. Look at the graph at right of a function. So look at the graph at right of a function as inverse, because terrible grammar. If P of X is a function, Q of X is the inverse. Can you tell which is which? Why or why not? Okay, so one of these is the original. So we'll call P of X the original. We'll call Q of X the inverse. So which one is P? Like, is that P? Is that Q? Or is it the other way around? Or does it matter? What do you think, Jack? Exactly, yes. Um, so can you tell? No, because they are inverses of each other. So it actually doesn't matter which one you call the original, which one you call the inverse. It actually doesn't matter. We just don't know. That could be P. That could be Q. Like this could be P. One's a vertical, one's a side Q, or vice versa. I don't know. If I were to come up with an equation, I think try to estimate. I don't know. This could be y equals x plus 2 cubed plus 2, I think. And the inverse of this would be then y equals cube roots. Give me a sec here. X minus 2 minus 2. They're inverses of each other, so we don't really know. So this is just more just to give you some conceptual understanding. Like, hey, if one's the original, one's the inverse, it could be the other way around too. It goes back and forth. Like, for example, what if I have y equals x squared and y equals plus or minus root x? So it'll look like this. I call either one the original. Doesn't matter. So, okay, let's move on. Okay, here. Consider a table to write an equation from the table that you see. Make a table for the inverse. How are the tables related to each other? Use relationship to find a shortcut for changing the equation original to the inverse. Solve the equation for y, and justify the inverse of each other. So let me walk you guys through 540, and then 540 I'll do part A and have you guys kind of do the rest. And then I'll talk about this other page here. And we got some more stuff to do as well. Okay. So let's talk about this guy here, 540. Anyone want to tell me what they think the equation will be for the table? And we'll call this the original function. Bless you. So, slope is 12. Close. You're almost there. Not quite 12. Pierce, go ahead. So 6x is definitely the slope. So 6 is the slope. Yeah, because that goes up 12. And that goes up 2. And just make sure it's consistent. Up 12. Up 2. Okay, so we're cool with that 6. And then solve for the y-intercept. You could do this. Plug in -5 for y. I mean, obviously, Pierce, you're right, but I just want to just show why you're right. You get -11. So the equation, I'll just clear everything, is y equals 6x minus 11. Now, Pierce, I guess what you probably did you just go 6 backwards from the first point? Yeah, that's actually a better way. If you just look at the table, well, yeah, if I just keep going 6 backwards, I get x equals 0. When x is 0, that's what x is. So it works. Be good. Next up, make a table for the inverse. That's easy. Just swap the columns.
Is there any mathematical way to try to find it, or is it just like you got to look for patterns?
Look for patterns. Well, if I'm going to ask you around an equation, I'm probably going to give you a linear. Just I mean, that'd be kind of cruel if it's not linear.
Yeah.
Yeah. So um, if the nerds get upset, I'll probably do that to you guys. I'll be cruel. Just kidding. So separate sports from work. Okay. But I won't be happy if we lose. Yeah, just swap the columns. That's all. So how are they related? Well, they're inverses, right? Or how they're related? Well, I think I already answered that question, right? How are they related? I just swapped the columns. So yeah, that's just kind of dumb question. So C, I basically answered C in part B. Now use the relationship between the two to find a shortcut for changing the equation in the original. So the shortcut is this: swap x and y, then isolate y. That's all. Do you get y by itself? Um, I think the best version of isolation that's all it's
a little different than that.
Yeah, exactly. That's what works. But yeah, when I swap, you guys see the slope would be here? 2 over 12. 2 over 12, so 1/6. Yeah, which makes sense. But what you could do is just swap x and y from an algebraic perspective, swap x and y, and get y by itself. And there you go. X plus 11 over 6. Which makes sense because you should be adding 11 to divide by 6. And so I just did this. So all this right here, I did both D and E at the same time. Yeah. Well, look at our table. Right? Our table starts at 1. And our slope is 6. So if we going backwards, you have to go down 6. Right? If you're taking 1 away from that, you got to take 6 away from it. Because that's -6 or -1, which is still 6. Yeah. Okay. And then justify that they're inverses of each other. The justification part, I'm gonna show you a better way for justifying, but for now, to justify, you can do this. So what was the original again? The original was 6x minus 11, right? What was the inverse? The inverse was y equals x plus 11 over 6, right? So what I would do is make up a number. What if you let x equal 1? What does y equal for the original? If you let x equal 1, what does y equal, guys? Perfect. So now, let x equal -5. Because it's an inverse, right? You should be able to get 1 now. If I put -5, it was -5 plus 11. 6 or 6? 1. Okay, there we go. That's how you verify it. There's yet another way, which I'll teach you guys later in this notes. But for now, that totally works, right? Just plug a number into the original, see what y equals, and then let that y value be the input for the inverse. So you always let output of original become the input. This is actually kind of a big deal. And I sometimes work with AP calculus students at other schools, and there's a well, I don't say you guys know what derivatives are. There's a calculus technique called a derivative that you apply to inverse functions, and they almost always mess it up because they forget this factor. They forget this factor. The output of the original is the input to the inverse. So I just want to really want to drive that home. That's kind of the key concept here, the key idea. Put a little star there because it's a big deal. Okay, so let me start with part A for 541. And then I'm going to have you guys do B, C, D in your table groups. So again, you're going to switch X and Y and solve for Y. So now X equals 2 parentheses Y minus 1 cubed. Makes sense, right? That's step one, right? So just to annotate, swap X and Y, right? Okay, now I get Y by itself. And you got a cube root. See here. And last step, guys, what's my last step? Well, I already did that. Add one.
Starting about.
Oh, raised to 1/3 power. Yeah, let me write this more neatly because I'm trying to squeeze this in and it's kind of hard to read. So Y will equal 1 plus the cube root. Yeah, that's a little cleaner. Here we go. I like that. That's better. Okay, so that's part A. Going to do parts B, C, and D. I'll show you guys the answers in just a little bit. I'm gonna freeze my screen. Take a few minutes. I'll come and help you guys out. Just gonna pull up CPM because um I just don't feel like working these out. They're not the most exciting problems. But if I have the answer key, why not, right? Yeah, I got the answers all queued up now. What's up? Sure. Yeah, I'm coming around. Which one now?
Let's see.
So you did a swap,
Yeah.
and then you subtract 20 first?
No, I
Yeah.
divided by.
Yeah, because you're driving 3, you're divide that by 3, 20, right?
Right.
Yeah, guys, make sure you're undoing things correct. That's why also I'll bet on the literal equations. Remember, like, there's a bunch of letters and I like get one letter by itself. Those are more challenging than these, but still, regardless, you have to be comfortable with the algebra to get a letter by itself, right? So once you do the swap for C, for example, right? Subtract the 20, then divide it 3, and then keep isolating. So you have 5 isolated. So if you got your minutes, like you got it. Yeah. You did a swap, you subtract 3 squared. Good. Excellent. Then you did a swap, subtract 20. Not quite for this one. This is myself. Yeah. Yeah. And here, the swap, like 6, both of them 3/4. Yeah, good work. Excellent. Yeah. Yeah. How you guys doing here? Questions so far? Or which one are y'all okay. Okay.
So I just want to.
Yeah, go ahead. Yes. Yeah, it was just multiplied by 3/4.
Yeah.
Yeah, same thing. Yeah.
Can you check sometimes?
Sure. And actually, let's balance the break. Yeah. Which is like your Sacramento, but I'm actually at this for the weekend, so I'll bring it down. Yeah, sorry. Yeah, because I realized it wasn't a house here, so yeah. So I'll let you know what
Yeah,
happens.
Steve, thanks.
See. Where's the answer for C? Against okay. Not quite. That seems a little off to me. Actually, no, you might be right. You might be right. I think you're right. Yeah, we'll split. Okay, let's split the answers, guys. I want to. So it seems to be 3/4. Yeah, because most of them are simple 4/3.
Oh,
3/4.
3/4.
3/4. Yeah, we should be fine. Okay, let me show you guys the answers, guys. Let me unfreeze my screen. Come on. Here we go. Oh, geez. What did I just do? Okay, sorry about that. Okay, here are the answers. I think for the most part, it's looking pretty good from what I'm seeing. Again, um, actually, Ben, you're a little off the C, so I guess we did wrong with that one. For part B, there's a restriction. Let me explain why there's a restriction. Um, going back to the original problem. How's that graph look? The graph looks like this: 2 right, 3 up. And the inverse was this: y equals x minus 3 squared plus 2. Now, if you graph the whole parabola, it would look like this. But then it wouldn't be a reflection about y equals x, right? So you only graph a portion of it. You only graph that portion. How do you tell? Let's go back to the square root function again. Let's talk about domain range for the square root function. What's the domain here for that radical function? X is greater than or equal to 2. And what's your range? Right. So when you graph this, we know how to graph parabolas. You guys have that many times, right? However, you have to make sure the domain range is consistent, meaning that if you swap these, it looks like this. So this is a domain of all real numbers, which you don't want, because the inverse is supposed to be the reverse of the domain range from the original. So the domain is only supposed to be x is greater than or equal to 3. So I'm only going to keep the right half of it to be consistent with that domain. And also the fact that the line y equals x goes right through the middle of it too. So they're mirror images of each other about y equals x. That's one little thing that's a little kind of sneaky. Trust me, even my AP Calculus students, they have a hard time sometimes realizing that. So we'll keep working on that. But the answers again are right here. Those are the answers. Any of those you want to go over that you may have messed up? You're not sure why you messed up? No. Yeah, Paul, good. Mhm. You could distribute the three if you want. It's up to you. So it doesn't matter. Yeah, not necessary. Hunter, go ahead. Mm-hmm. Get 3x minus 18. Same thing. Same thing. Not a problem. Okay, let's keep moving. Okay, 542. Okay. Okay, so Talia has an idea for checking that functions f and g are inverses. Okay, so she thinks of stacked function machines. Okay, fair enough. She starts by choosing input to drop in f of x. Then she drops the output from f of x into g of x. If she gets her original number, she's pretty sure the two equations are inverses. The answer is yes. It will work. And we're going to prove it. We're going to prove it right now. So I kind of save you guys a heartache. I'm just telling you right now, the answer is yes. So let's plug in 3 into the first function machine. If you plug in 3 here, what do you got? Sorry, say again?
-1.
But -1, right? It's 26. Now, we'll switch colors for a bit of contrast. Let's throw 26 into the g function.
3.
You get back to 3. It comes full circle. You get 3. Yep, and there we go. Yeah, good. Oh yeah, you can walk there. All right, okay. Anyway, yeah, so that's what happens. So the answer is yes, it did work. So the notation f of 3 represents the output when 3 is input. What does g of f of 3 mean? So g of f of 3 basically represents, well, actually, I don't know what they mean by that. Hold on. Let me look at the answer key. I'm a little confused by that question. Says, wait, what? What's the question asking? I'm not sure what they, well, I mean, what it means, and I mean, I don't know what they're trying to get at that question, but what it does mean is that the output for f of x when x equals 3 will then become the input for g of x. I think that's what they want. I don't know. It just seems kind of a weird question. But that is true. Yeah. You plug in f and that output will now become the input for g of x. I'm guessing that's what they want. So, okay, we're almost done with the notes. And then you guys can get started with homework. We're going to talk about composite functions really quickly. So I'm going to do part A for you guys. And then I'm going to have you guys do B and C. And then we're done. And then you guys can get started on homework. And homework is attached to this packet, just so you know. It's just this page. If you want to do extra problems, you can. And I'll put the answers while you guys are working. Okay. So 545, last one. Verify that there's inverses by showing this algebraically. So let me show you how this process is done for part A. Okay, so we're going to put g of x into here. So I'm replacing these x's here with g. So I'm replacing the x with g. So if I keep going, it looks like this. And what's g of x? 5/3 x plus 25. Now distribute. I'm taking a little bit long-winded approach because I want to make sure you guys don't mess it up. If I do that, and by the way, let me get a highlighter here so it stands out. I'm sure it's the best highlighter to use, but we'll go with it. Okay. What's 3/5 times 5/3, guys? What happens here?
One.
Well, it's 1, so you can get x. Okay, good. Okay. You can use calculator if you need to, or just think about it. What's 25 over 5? What's 3 times 5? Or if you do 3 times 25 first, which is 75. 75 over 5 is 15. You get that from regardless. So you have plus 15 minus 15. What happens to the 15s? They cancel. Where are you stuck with? X. So f of g of x equals x. So let me add a little note here. I'm running out of space. When this happens, then f and g are inverses of each other. Also, g of f of x will also equal x. Okay, so when this happens, when you plug a function into another function, you get x coming out. That means they're inverses of each other. Technically, should do it the other way around just to make sure they didn't make any mistakes. Like technically, you should do g of f of x. You should, but you know, it's okay. Just, as long as it shows me once, okay. So do the same thing for B and C. Plug G into F, or D into E, I guess, for part C, and prove that the inverse is by getting X in the final answer. The final answer should come out as X. So what you're going to do for parts B and C, again, I don't want to erase what's on here because it's kind of good to see what I just did. Oh, come on. Do you remember? Do that. And clean it up. So I would do it right now. Just do B and C really fast. You should get X each time. And after that, we're done. Hey, go ahead. Yeah. Yeah, totally. Yeah. Let's see. What's up?
Um, so like for this one, I got to go, and then you just like keep starting.
Yeah, you keep going. Because you're gonna get 3x minus 30 over 3. So when you have 3, no, you're doing great. So 3x minus 30 over 3 plus 10, then divide each of those by 3, and then you got it. Yeah.
Okay.
Yeah, just keep going.
Okay.
Yep.
Thank
Okay, let me just walk around and make sure you guys getting X. That's fine. Good. You got X. We're still working to be okay. So keep going. You're doing great. What are we gonna do for this? So what you want is distribute the two, right? So g of x minus 21. Yeah, yeah. So if you distribute the two, that becomes 3x minus 42 plus 12. And then you still have 3 on the bottom. But keep going. You're doing great. Keep going. Distribute. Yeah. Yeah, yeah, yeah. 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 You should always get X in the final answer.
you.
Okay. You have the C.
Sorry.
Yes, the C. Yes, you plug this into this, or the other way around, it's up to you. But you plug this into this. Good. Yeah, you're doing great. Keep going. So first off, hold on a sec. Can you just cross these and see what reason? And I should do that. Should be 6 and X with 4, but wait, that's weird. Wait, UV. Plug in 4 actually to be. You get 4. That's so weird. I guess it's a typo.
Oh, okay.
Yeah, it should be 2. Yeah. Hey guys, there's a typo for part C. Yeah. This should be a 2 root x plus 10. Just saying, should be a 2 root x plus 10. This is a typo. So, all right, I'm gonna end the lesson and have you guys start homework. Homework is right here. It's attached. So someone's old stuff, right? Some's on what we just talked about today. 49 is obviously old stuff, 50 is old stuff. 51 is obviously new stuff. 54 is old stuff. Um, yeah. So anyway, and I'll put the answers up in just a little bit. So, all right, let's get started on homework. Yeah, Gus, go ahead.
Is the typo, is it 2 times that, or is
No, it's usually 2 root x plus that. That force be 2.
or is it like it's 2 times?
Of course, yeah. Yeah, sure, good.
Wait, I got to here. Let's see.
Yeah, so they should be fine then, because that becomes 4x over 4.
And the 4's cancel, you get x. We square the 2 with x, so it becomes 4x over 4.
Oh.
Yeah.
This should be fine. Okay, I'm gonna stop the recording.